So I want to welcome everybody to this second IMS virtual conference session. The first we had today was from Subhadesh, who's doing this session, another session related. So the first session at 9 was on the SM1 SL0 input message sending to IMS Connect and how that works, which is obviously the easier one. And now it's getting a little more difficult with the SM1 SL1 message type. So in IMS Connect, and how there is the interaction between IMS and Connect for that one. So this session is on how SM1 SL1 input messages sent to IMS Connect works. And there's various scenarios, including the obviously when it's successful and when the sync point fails. So this is the IMS stream second session, and it's session 5B in your schedule. So thanks for joining this. Now, just to clarify, I've already posted, but Subhadesh is saying that you can ping him questions, as in you can actually verbally ask them. So if you do that, then I will sort of unmute you or ask you to unmute yourself, and then you'll have to unmute yourself for that question to be asked. So just bear that in mind. So there might be a short delay if you've got a question, but verbal questions are okay for this session. Now, just saying, if you haven't joined the first session, then Subhadesh has been in BMC software for over 7 years now, and he is a Army expert for BMC, and he's been doing in the IT industry for over 15 years now. So he's got lots of experience of IBM Z mainframes. So without further ado, I'll just pass over to Subhadesh. So welcome again, Subhadesh, for the second session.
Thanks, Tom. Thanks a lot for the introduction, and welcome everybody to this session. It's great to have all of you. Thanks for joining in. So as Tom alluded to, the first session was basically talking about CM1 SL0 input message being sent by an IMS Connect client to IMS Connect. And which was, as Dom said, that relatively simpler protocol of sending messages in OTMA. Now we are going to get into a bit more complex protocol, which is the combination of CM1 and SL1. So this is definitely going to be a lot more interesting. But before going into the details of the session, as Dom mentioned, I am working for BMC Software as a product manager looking after the BMC AMI data for IMS portfolio of products or solutions. I have been working for BMC Software for a little over 7 years now. So, yeah, so that's a short introduction about me. And now I'll go into the session. Before I can do that, just let me fix the sharing portion. I am not sure whether, so are you able to view the opening slide that I'm sharing right now, Dom?
Yes, we can see that.
Okay, great, thank you. Yeah, so let's get into the session. As mentioned, this is a session about CM1 SL1 input message being sent by an IMS Connect client to IMS Connect. And we will look at how this entire thing works. Yeah, so what is this session all about? In this session, I'm going to talk about what happens when an IMS Connect client sends a CM1 SL1 ACK input message to IMS Connect. And I'll talk about both the cases, when the sync point completes successfully and there is a failure of sync point. Also, I'll talk about a third scenario when an IMS Connect client sends a CM1 SL1 input message to IMS Connect, but this time, instead of the IMS Connect client sending an ACK or a positive acknowledgement, the IMS Connect chooses to send a negative acknowledgement, or what we call a NAC, right? So we will, in theory, we will talk in detail about all these three different scenarios. So to start off, we'll start with the basic scenario of what happens when an IMS Connect client sends a CM1 SL1 input message to IMS Connect. So for the moment, let's leave the ACK and the NAC part aside. So let's concentrate on the basic scenario. What happens when an IMS Connect client sends a CM1 SL1 input message to IMS Connect, right? And then we will get into the scenarios later, because there are some common steps that actually happen between all the three scenarios. So let's go through those common steps first, and then the steps which are specific to a particular scenario, I'll come to those steps later. So just before going into this specific broader view, let's do a basic introduction or a basic fact check about the different terminologies that will be used here. And this is only going to be an introductory. I mean, I'm only going to introduce the terms at a very basic level, because the session is not meant to dive deep into the terms. But in order to level set the session, I'll just explain what those terms mean in a very brief manner. So the IMS OTMA client, and as you can understand, OTMA stands for Open Transaction Manager Access. So the IMS OTMA client generally communicates information to IMS, as well as the client can receive information from IMS in a prefix, which is passed in front of the message or the IMS command. It can be both ways. But the important thing is there has to be a prefix for an OTMA transaction happening between an OTMA client and IMS. Now, there are several levels of information, and the level of information can really go very deep and very complex. But for our session, we are interested in two specific information that are present in the prefix, which are commit mode and synchronization level, or in short, which we call sync level. Now, there are two different commit modes, commit mode 1 and commit mode 0. I'm not going to talk about commit mode 0 here. There is a third session I'm doing on, I think, day after tomorrow, wherein I will talk about the commit mode 0. But for this session, I will limit myself to commit mode 1, which we are interested in. So commit mode 1 refers to, obviously, CM1 refers to commit mode 1, and commit mode 1 is basically the send then commit mode. So as you can understand, the name itself suggests that IMS will send the reply message. IMS receives the transaction input message. It processes the input message. It generates an output, and it sends the output or the reply message without actually committing the workflow, right? So the output message is sent to the client first, and then the commit work or the commit activities happen later down the road. And we will take a look at how those things work. But in short, commit mode refers, CM1 refers to send then commit mode. Now, for SL1, which is synchronization level 1 or sync level 1. So for SL1, when the OTMA client gets the reply message, it has to send an acknowledgement for the sync point to continue. Now, that acknowledgement could be a positive acknowledgement, which we generally refer to as ACK message, ACK message, or it could be a negative acknowledgement as well, which is usually referred to as a NAC message, NAC message. But the important thing is for SL1, when the OTMA client gets the reply message from IMS through IMS Connect, it has to send an acknowledgement back to IMS in order for IMS to continue with the sync point process or the commit process. However, the OTMA client should still not process the reply message until it receives the deallocate response back from IMS. So in short, IMS sends the reply message to the OTMA client. The OTMA client has to send an acknowledgement to IMS for the sync point to continue. But in spite of the fact that the OTMA client has received the reply message from IMS, it is not entitled to process the reply message until it receives something which is called a deallocate response message back from IMS. So in short, for SL1, the OTMA client must send an ACK or positive acknowledgement or a negative acknowledgement on NACK for the output or reply message. A short introduction about IMS Connect. IMS Connect is an IBM provided OTMA client for TCP/IP, which is in very simple words, IMS Connect is the TCP/IP gateway for IMS, right? And it's as simple as that. And I might interchangeably use the terms IMS Connect and Icon. So, bear with me if you hear the term Icon. That is basically a shorthand for IMS Connect. So IMS Connect or Icon will send the output or reply message to the Icon client, and wait for the ACK or the NACK from the Icon client, which is then sent to OTMA. Now, there is a timeout feature in OTMA while waiting for the ACK or NACK. I mean, OTMA cannot indefinitely wait for the ACK or the NACK, right? The IMS client might go down, right? We may lose the IMS Connect client, and IMS and OTMA cannot indefinitely wait for ACK or NACK from the client. So there is this timeout feature which is present in OTMA while it waits for the ACK or NACK from the OTMA client. And in our case, the OTMA client is always the IMS Connect client. So we are talking about IMS Connect here.
Subhadash, can I just ask a quick question? In that,
sure.
Can you vary the timeout number, as in the value?
Absolutely. Yeah. So I think there is a default. I don't remember on top of my head what the default is, but absolutely, yeah, you can do that.
Okay, thanks.
Yeah, right. And in fact, that is the recommended thing to do. In production, it's not recommended that you go with the IMS default. I mean, every shop is different. The volume of transactions vary, so the timeout should obviously be different. The IMS Connect client will get another output or reply message after IMS Connect receives the deallocate message from OTMA. And I also said this in my first session that all the things that I'm going to talk about here, normally some of these things do not apply to a conversational processing. The conversational processing is a different ball game and a different beast altogether. We are not going to get into the complexity of a conversational processing here. I'm leaving out that part. Right. So yeah, and let's now get into the detailed process of what happens in the background when an IMS Connect client sends a CM1 SL1 input message to IMS Connect. And then to start off, I'll talk about the common steps between the three different scenarios. And as the steps start to vary between the different scenarios, I'll talk about them later. But I guess for the first part, quite a few number of steps in the beginning are the same for the entire workflow. So we'll talk about those at the beginning. So to start off, the IMS Connect client will send a CM1 SL1 input message to IMS Connect. IMS Connect, obviously, after it receives the CM1 SL1 input message, it will allocate a control block for the client and the control block is called an SVT control block. And obviously the control block is created if it does not already exist. And then the input message is sent to IMS OTMA through the XCF, the cross system coupling facility. The transaction pipe name or the T pipe name is usually the port number that received the input message. So that's how the transaction pipe or T pipe gets dynamically created in the background. It's usually the port number. I won't say it's usually the port number. It's actually the port number that received the input message. So now OTMA starts processing the input message, which it received from IMS Connect, which received it further from the IMS Connect client, from its client. So OTMA, after receiving the input message from IMS Connect, it obviously starts processing the input message. Now, the moment it does that, it creates a control block, which is called a TIB or a transaction instance block. And this control block is allocated by OTMA. A few other things also happen depending upon the level of security that is set up in your OTMA, OTMA and IMS Connect code, or OTMA and IMS Connect processing environment. So a system authorization facility or a SAF product, RACF, for example, can be called if needed. Again, depending on the level of security that is set up. And these days, I'll say that almost all the shops will actually have this strict security measures in place, right? So any security, any system authorization facility or SAP product is definitely going to be called. The input message will then, and it's a standard protocol now, the input message gets first inserted into the IMS message queue, and then it gets enqueued on the transaction queue. So it's all very standard, nothing fancy here. Now, next what happens is the IMS application program will now come into the picture. What it does is it will do a get unique or a GU to the IOPCB, the input output program communications block, in order to retrieve the input message, right? It's very basic. The input message will then be processed by the application program, by the IMS application program, as per the logic that has been coded within the application program. And then after the input message is processed by the IMS application program, the program will do an insert ISRT of the reply message to the IOPCB. Now, the reply message gets anchored on the TIB. Remember, I talked about the transaction instance block or the TIB control block being created by OTMA when it received the CM1 SL1 input message from IMS Connect. Now, when the IMS application program, after the IMS application program does an insert of the reply message to the IOPCB, the reply message is immediately anchored on the TIB control block. And then IMS OTMA will retrieve the reply message from the message queue, right? The IMS OTMA will send the reply message to IMS Connect through XCF. And now, after IMS OTMA sends the reply message to IMS Connect, IMS OTMA at this point, IMS OTMA waits for an ACK or a NAC, a positive acknowledgement or a negative acknowledgement from IMS Connect, which actually comes from the IMS Connect client, right? Now, at this point, the sync point processing, the database logs, external subsystem logs, for example, DB2, MQ logs, etc., are all held up. And the message processing region or the MPR remains occupied at this particular point in time, because now IMS OTM is actually waiting for the ACK or the NAC in order to start the sync point processing. It cannot do that until it has received some sort of reply from the client side. Now, IMS Connect at this point will also anchor the reply message on the SVT. Remember about the SVT control block that I talked about. when IMS Connect receives the CM1 SL1 input message from the IMS Connect client, it had actually allocated an SVT control block for the client, right? So IMS Connect will anchor the reply message on the SVT control block. Now, IMS Connect will now send the reply message to the IMS Connect client and will wait for the ACK or the NAC. Now, till this point, whatever I've talked about till now, till this point, the flow is the same for two scenarios. So the number one scenario is the IMS Connect client has sent a CM1 SL1 input message to IMS Connect, and the IMS Connect client sends an ACK or a positive acknowledgement. And the second scenario is the IMS Connect client could also send a NAC or a negative acknowledgement. So till the point, till now, till where I have talked about, IMS Connect has sent the reply message to IMS Connect client and it's waiting for the ACK or NAC. These steps are common, right, for both the scenarios. Now, if for the positive acknowledgement, let's consider the case of the positive acknowledgement first. IMS Connect client will get the reply message, and IMS Connect client gets the reply message from IMS Connect, and now it has to choose between sending an ACK or a NAC, right? Now, since we are considering the case of a positive acknowledgement, let's say that the IMS Connect client, after receiving the reply message, it sends an ACK, positive acknowledgement. So the IMS Connect client holds the reply message and waits for the deallocate message to see if the sync point completed successfully, right? So remember, I talked about this in the first session. I'll talk about this briefly. So even though the IMS Connect client has received the reply message at this point, and it has already sent an ACK out to IMS Connect, it still cannot go ahead and process the reply message. It cannot do that because remember, IMS sync point processing hasn't completed yet. So the client cannot simply go ahead and send out the reply message to the end user. So it holds the reply message back and it has to wait for something which is called the deallocation message or the deallocate message. So the deallocate message basically indicates the status of the sync point, whether the sync point processing completed successfully or whether it failed. So the IMS Connect client at this point has sent out an ACK, but it cannot process the reply message. It's holding the reply message and is actually waiting for the deallocate message back from IMS. Now IMS Connect receives the ACK message from IMS Connect client and it sends the ACK message out to OTMA. Now the sync point processing will start. Now, technically, there's something called a phase 1 and a phase 2 sync point. You can choose to neglect that. It's basically sync point, but technically what happens in the background is two phases of sync point happens. So when the sync point processing begins, first OTMA will start processing the sync point, and that is technically which is called the phase 1 sync point. Now, let's assume that the phase 1 sync point completes successfully. There is another case. So there is another diversion that we are going to take, wherein this particular case, we are assuming that the phase 1 sync point completes successfully. Now there is another diversion which I'm going to talk about a few minutes later, wherein the phase 1 sync point will actually fail. But let's hold off let's hold that off for a few minutes. At this point, let's assume that the phase 1 sync point completes successfully. So now, since the phase 1 sync point has completed successfully, so that is the OTMA initiated sync point has completed successfully. What OTMA will do is it can now safely send the deallocate message back to IMS Connect. Remember about the deallocate message that the IMS Connect client is waiting for? So now, since the OTMA initiated sync point has completed successfully, OTMA chooses to send the deallocate message to IMS Connect. And for a sync point success case, the deallocate message is called the deallocate confirm message. If the sync point had failed, the deallocate message would have been called a deallocate abort message. So in this case, we are considering that the OTMA sends the deallocate confirm message to IMS Connect because the phase 1 sync point has been assumed to be completed successfully.
So
Now, yeah,
sorry, just a quick
no
one.
problem.
So therefore, in that, when that's waiting for that deallocate confirm, that is also when a lot of the application processing is taking place, because it's at just before the phase 1, the phase 1, isn't it? So effectively, it also has to do its application processing.
Right.
Or is
Well, not
that a step further?
Yeah, well, not actually, Dom, because if you look at it, let's consider this entire thing as a unit of work, right?
Yeah.
So at that point, the application, remember, the application program had already processed the input message, and it had actually generated a reply for the IMS Connect client, which was actually sent to the IMS Connect client. But you're right. The application program hasn't terminated at this point. It's actually waiting for the phase 2 sync point to complete. So the application program is technically on hold, waiting for completion. It's not processing anything as such because it's a single transaction, it's a single unit of work. But yes, it has not fully completed its execution in a sense that it has not completed its termination process. So it's about to complete the termination process and waiting for phase 2 sync point to complete successfully.
Okay. Fine.
Yeah, right. So OTMA sends the deallocate confirm message to IMS Connect, and the moment OTMA does that, remember the TIB control block that was on hold, where the reply message had been anchored by OTMA. Now, since the OTMA has already confirmed the generation of the deallocate confirm message, it can safely go ahead and delete the TIB control block. If you think about it, it doesn't need to keep the TIB control block any longer, because from its viewpoint, the sync point that it had initiated, namely the phase 1 sync point, it has already completed successfully. So at this point, OTMA deletes the TIB control block. And then now, to answer Dom's question, the phase 2 sync point completes successfully. Now the application program gets a notification from OTMA saying that, hey, application program, I know you are waiting for me. You are waiting to terminate yourself and pass the control back. Hey, you know what? I have completed processing the sync point which I had initiated from my side. So you can go ahead and complete the sync point from your side as well. So it is this point when the application program sync point, which is technically called the phase 2 sync point, also completes successfully. Now, IMS Connect, at this point, IMS Connect will send the deallocate confirm message to the IMS Connect client. Remember, the IMS Connect client was actually eagerly waiting for this deallocate confirm message till now. So now IMS Connect can actually take that deallocate confirm message, and it can send the deallocate confirm message to the IMS Connect client. Now, if a persistent socket is in use, I'm not going into the details of persistent sockets and things like that. But if a persistent socket is in use, then IMS Connect will not terminate the port connection. It keeps the port open. IMS Connect keeps the connection open and does not free the SVT control block, right? So or otherwise the SVT control block is free. Remember, at the start, I had mentioned that when IMS Connect client receives the CM1 SL1 input message, when the IMS Connect client, when IMS Connect receives the CM1 SL1 input message from IMS Connect client, it allocates a control block for the client remember I had mentioned if it does not already exist. Now you probably understand why I had used that term, if it does not already exist. It's because of this persistent socket. So if a persistent socket was being used for this entire workflow, then IMS Connect will still keep the connection open and it will not free the SVT control block. Right? So the next time another CM1, SL1 input message comes in, the SVT control block need not be reallocated again. Or otherwise, if a persistent socket is not in use, then the SVT control block is freed. And then now that the IMS Connect client has received the deallocate confirm message, it knows that the entire sync point processing on the side of IMS control region, on the side of OTMA is successful. It can safely go ahead and process the reply message. So now this is the entire flow for an IMS Connect client sending a CM1, SL1 input message to IMS Connect, and the IMS Connect client chooses to send a positive acknowledgement back to OTMA, right? Now let's take a slight twist to the entire story. The second case is the IMS Connect client is sending the CM1, SL1 input message, but then this time the IMS Connect client, instead of sending a positive acknowledgement, what it does is it sends a negative acknowledgement or a NAC. So I'm going to pick up from the point. I'm not going to go through the entire scenario again. I'll just pick up from the phase one sync point, right? So remember the sync point processing occurs, starts happening on the OTMA side first. So OTMA initiates the sync point processing process and phase one sync point begin. So in this case, the phase one sync point will actually fail, right? So I'm actually I made a mistake over here. So the second case that I'm going to talk about is the IMS Connect client. So let's let's set aside the confusion. So the first case that I talked about was, let me go back. Let's not confuse this. The first case that I talked about was the IMS Connect client sends a CM1 SL1 ACK input message to IMS Connect. It's the client sends an ACK and the sync point completed successfully. The next case I'm going to talk about is the IMS Connect client sends a CM1 SL1 input message and the client sends an ACK, but the sync point failure occurs this time. Instead of the sync point happening successfully, a failure occurs. So when OTMA initiates sync point one, phase one, let's say that this time the phase one sync point fails, right? So this time OTMA chooses to process the failed sync point, but then this time OTMA will send, remember the previous time when the sync point succeeded, OTMA had sent what we called the deallocate success message, right? The deallocate confirm message. And this time when the phase one sync point fails, OTMA sends the deallocate abort message, plus it also sends a notification out to the client saying that there is some problem in the process. So it's done through a DFS XXX message. So in case of phase one sync point failure, OTMA processes the failed sync point, number one, and then number two, OTMA sends the DFS XXX message and the deallocate abort message to IMS Connect, again through XCF. And these messages can arrive in IMS Connect through XCF in any order. It's not necessary that DFS message arrives first or deallocate abort message arrives second. It doesn't matter. It can arrive in any order. Now, OTMA will delete the TIB control block at this point in time. Again, OTMA does not need to hold the TIB control block. The sync point has failed. There is no point holding the TIB control block at this point. It goes on and deletes the TIB control block. Then the phase two sync point will also fail. So the phase two sync point, as we know, technically it's the application program sync point, right? So the application program sync point or the phase two sync point will fail, which in turn means that the application program will abend at this particular point in time. So IMS Connect will process the sync point failure and it will send the DFS XXX message to the IMS Connect client. Now, again, if a persistent socket was in use, IMS Connect will keep the connection open and it will not free the SVT control block. Otherwise, the SVT control block will be freed. And finally, the IMS Connect client will process the failed sync point and it will discard the reply message. Remember, it was actually holding the reply message and it was actually waiting for a deallocate confirmation message from IMS, just to understand whether the point completed successfully or it failed. So in this case, since the sync point failed, the IMS Connect client will process the failed sync point and it will discard the reply message. The IMS Connect client will process the DFS XXX message instead. So this is all about the two different cases that I have discussed till now. There is a third case, but before going to the third case, let's do some practical demonstration of how this entire process works. So now we'll practically try to understand the CM1 SL1 ACK flow. And for this, I have chosen to use a product which is called the BMC AMI Energizer for IMS Connect product in order to demonstrate the behavior of CM1 SL1 ACK. And again, I'll stress on this point. I'm not trying to do a sales speech for any BMC product here. That's not my point. I am only using the BMC AMI Energizer for IMS Connect product because, you know, that is what is available, readily available to me to use, and that too for free, right? I mean, remember, I'm the product manager looking after all the IMS products, and BMC AMI Energizer for IMS Connect is one such product. So I get to use this product for free. So that's why I have used this product to demonstrate the behavior of how CM1 SL1 ACK behaves. Now, as you can probably, by looking at these two screenshots side by side, you can probably understand that I have executed the part transaction over here. So you can see over here part, the famous IBM part transaction. I have chose to use, I have executed the part transaction as I did in my first section as well. So just to be consistent between my different sessions. But do take note of a few options here. So if you take a look at, carefully take a look at the first screenshot, you'll see that I have selected the protocol of CM1 send commit, which is the commit mode that we are working with. We are working with CM1, right? And then if you take a look at the confirmation, I have selected confirm ACK. So this denotes that I have chosen sync level SL1 ACK, right? Which is exactly what we intend to do. Now, if I break down the transaction execution into parts, let's go through the first part. So in the first part, it's very simple. What I'm doing is the transaction, the part transaction gets sent out to IMS. So over here, if you see the part AN, whatever, this transaction is sent to IMS, and you can see this over here. This is the actual message that is sent out. Then in the second part, what happens is IMS has sent the reply. Remember, now try to map this with the flow that we have talked about till now. For CM1 SL1, IMS receives the input message, it processes the input message, and then it generates the reply message and it sends the reply message out to the client, right? That is CM1. The sync point hasn't yet started yet. So IMS has sent the reply back to the client. And now if you look over here, the flag is set to ACK/NACK required. So this ACK or NACK required denotes SL1. So this is denoting synchronization level 1, and this is basically this basically states that the OTMA client has to send an acknowledgement, positive acknowledgement, or positive confirmation. In this case, we're talking about ACK, positive confirmation, to OTMA for the sync point completion. Now, there is also another interesting thing over here. If you see over here, the CSM segment. So this CSM, as you can see, it stands for complete status message, right? It basically says that any successfully processed output message from the IMS Connect message exit sent to a client contains this CSM segment, which is the complete status message segment. And the important thing to take note over here is the CSM OKY. So this CSM OKY actually stands for stands for what we call the CSM OK. So which means that the output reply message sent by IMS to IMS Connect has been successfully processed through the IMS Connect message exit and sent back to the client. So that's what it means. In short, in very simple words, till now, everything is working fine. Now, the third part, if you see over here, try to trace back to what we talked about. IMS Connect client, it has received the reply message back from IMS. Now it has to send either an ACK or a NACK. In this case, since I deliberately chose the IMS Connect client to send an ACK, what it does is the client sends an ACK. So if you see over here, this C1 and this A, this actually indicates ACK. So if you go to the IBM documentation, and you will have the IBM documentation clearly lays out the dissect for this. So this is just a mapping of the dissect. So this C1 and this A, this denotes that the client is sending out an ACK message to excuse me, to IMS Connect. And then the fourth and the final part, if you see over here, remember the IMS Connect client is holding up the reply message. It sends an ACK, but it still cannot process the reply message. It has to hold the reply message till it receives a deallocate message back from IMS. In this case, if you see over here, DIL CTD, which is deallocate confirm. So the deallocate confirm message, this states that the deallocate confirm message has been sent to the OTMA client back from IMS. The return code is 4 and the reason code is 97. And the receipt of the deallocate confirm message by the OTMA client means that the sync point processing was successful on the OTMS side. And now the OTMA client can go ahead and process the reply message. So by processing the reply message, maybe it was fired from a terminal. So the end user who is waiting at the terminal, waiting for the reply message, now sees the output of the transaction on the terminal. Right? So yeah, I think, yeah, that's it. And now what we'll do is we will go to our, I'm sorry. Yeah, we'll go to our third case. And remember, we talked about two cases, IMS Connect client sending a CM1 SL1 ACK, and then sync number one. The first case was sync point processing happened successfully. Number two was sync point failure occurred. The third case is the IMS Connect client will send a CM1 SL1 input message to IMS Connect, but this time, instead of sending an ACK, the IMS Connect client will actually send out a NACK or a negative acknowledgement. In the previous two cases, it was positive acknowledgement. But in this case, the IMS Connect client will send out a NACK or a negative acknowledgement, right? And I'm not going to run through the entire process again, but I'll pick up from where the actual changes apply to this particular case scenario. So again, So remember, IMS Connect sends the reply message to IMS Connect sends the reply message to the IMS Connect client, and it's waiting for the ACK or NACK from the IMS Connect client. In the previous two cases, at this point, the IMS Connect client had sent out an ACK, but in this case, the IMS Connect client gets the reply message and it sends out a negative acknowledgement or a NACK. Now, the IMS Connect client discards the reply message and it waits for the deallocate message. IMS Connect client, since it has sent out a negative acknowledgement to IMS, which means that there is some sort of problem at the IMS Connect client side. So there is no need for the IMS Connect client to hold the reply message any further. It's not going to process the reply message in any case. Right. So at this point, the IMS Connect client will disregard or discard the so at this point, the IMS Connect client will discard the reply message and it will wait for the deallocate message. IMS Connect will send the NACK message to OTMA. The sync point processing will begin at this point. So OTMA initiates processing the sync point, technically called the phase 1 sync point. The phase 1 sync point will fail, right? Because this is an entire unit of work that's happening, right? So if the IMS Connect client acknowledges that there is some sort of problem at its side, and it therefore chose to send a negative acknowledgement back to IMS, what it does is OTMA what it does is it fails the phase 1 sync point, right? So OTMA will process the failed sync point, and again, the protocol is same. It sends the DFS x66 message and deallocate abort message to IMS Connect through XCF. OTMA will delete the TIB control block. The phase 2 sync point will fail at this point, which in effect means that the application program will abandon at this point in time. IMS Connect will process the sync point failure and it will send the DFS x66 message to the IMS Connect client. Right. And again, if it was a persistent socket that was in use, IMS Connect will keep the connection open. It will not free the SVT control block. Otherwise, the SVT control block will be freed. And finally, the IMS Connect client will process the DFS x66 message. So with that, I have covered all the three cases, but then we will also take a look at we'll also take a look at the third case. We'll try to understand the CM1 SL1 client NAC this time. Again, the same screenshot, I've executed the part transaction, but just note the difference in the option that I've selected. In the protocol, it's the same. I've selected CM1 send commit protocol, but in the confirmation now I've selected, previously I had selected confirmation ACK. This time I have selected rejection NAC. Right. Again, let's break down the transaction execution output. The first part, simple. This part transaction is sent to IMS. Second part is IMS sends the reply. This ACK-NAC required denotes that we are using SL1, synchronization level 1 protocol. Right, the CSM is okay, which means that IMS Connect client has received the reply message from IMS. But in the third part, now the IMS Connect, instead of sending an ACK message out, it chooses to send a NAC message out. So this D5 and N indicates NAC. Right, so quite clearly the client, the OTMA client in this case, is sending out a NAC message. And then the final part is this is the difference from the previous. If I may just bring this down here. So excuse me, this is the difference over here. See, if you see over here, so this is the DFS x66 message that I was talking about. So DFS 555i. it says that transaction part abandoned, right? U0119 abandoned. And so DFS 555I message is received and it's processed by the client. And you would also notice the following messages in your IMS control region address space. So for example, these are some of the messages that you will also see in the IMS control region address space. The transaction part has abandoned, the user abandoned, and things like that. So in this particular case, as the client has sent a NAC, sync point failure happens at OTMA and the application abandons. So phase 1 sync point completes unsuccessfully, and phase 2 sync point also completes unsuccessfully, which results in the application program being abandoning out. And then when IMS Connect client knows that the sync point processing has completed on the side of IMS, it goes ahead and processes the DFS 555I message. So end user who had entered this transaction on the terminal waiting for the response, this time for this particular case, it doesn't see the response back, it sees the DFS 555I message. and he knows that there is some problem in the IMS system. I think with that, I have covered all the cases, and I will now I'm now ready to take on questions. And also Tom, if you would like to take it now from here.
Yeah, sure. So thanks, Subhadash, for that session. Everybody, if you've got any questions, then you have been able to field them or post them in or whatever, or via asking. But please do ask any questions for Subhadash at this point if you want. You'll have to unmute yourself as well, so I'll unmute everybody. Well, I'll ask everybody to unmute, so you'll just have to unmute yourself to do that. And if you haven't got any questions, then that's fine, but we've got feedback, so we're all interested in the feedback that you give for every session. So feedback is follow the QR code here at the bottom left, and also we've got the strapline of the online link that you can do feedback for this session as well, and it was session 5B. So have we got any questions? Anybody wants to open up for anybody? Any more questions? I mean, I've got just one simple one. What do applications design? Obviously, they will have to decide what they want in the negative or the acknowledgement, and that that's up to the design of the processing of what we're trying to do. So so if you're doing, have people got examples of acknowledged or NAC ones that anybody would like to mention on this call? So like an example.
Definitely, that would be interesting. Yeah.
So that's really just an open it up to everybody just for the next 2 minutes, 5 minutes.
Yeah, hi Subhash, it's Ajay here.
Hey, hi Ajay.
Yeah, so yeah, it was really nice session, and we came to know about the new feature and how we can set up and how it works behind the scene. So that was really great. Thank you for your time and presentation. So I have a couple of questions here. So
sure.
It is the same way that what we are talking about negative acknowledgement and acknowledgement is the same way how two-phase commit work, or it is a different as compared to that?
Okay, so if you are referring to two-phase commit, so technically this is not the two-phase commit that you are referring to. I think technically when you say two-phase commit, that involves a commit between IMS and a different subsystem. So maybe, yeah. So this is not that two-phase commit that we're talking about. This is that's why I hate to use the terms phase 1 sync point and phase 2 sync point. So it's basically the sync point processing that happens on the OTMA side of the code, right? So it's basically OTMA initiates the sync point processing, and that's what is called phase one sync point. And then when the phase one sync point completes successfully, then the application program, which had actually processed the reply message, but it had not terminated at that point in time. It was actually waiting for phase one sync point to complete successfully. And then when the phase one sync point happens successfully, application program terminates its sync point and passes the control back to IMS, which is basically the termination of phase two sync point. So yeah, it's let's not call it two-phase sync point. It's basically let's not call phase one and phase two. Let's call it OTMA and OTMA sync point process.
Yeah.
Okay.
So there's IMS.
That's IMS.
Phase
Yeah.
one and phase two, and then there's the connect
Right.
portion of it, which is what you're explaining with the NAC and the negative acknowledgement, etc. But they are, clients will have IMS connect with the IMS phase one and two commit with the, as you said, with other, so in IMS terms, it will be IMS, and sometimes people will have DB2 as well. So it'll be IMS and DB2 for the phase one, phase two. And then over and above that, you've got this connect explanation as Subhadash is giving us.
So thanks. So yeah, that clear out. But why did I ask this question? Basically because whenever, as Dom mentioned, whenever we are having this DB2 and IMS, right, or IMS is, so as of now, it is I should say IBM doesn't have any solution for it, to be honest. When wherever we are having IBM and IMS and DB2 are talking to each other, and in between of that, if any, and they are talking with each other with the wire stored proc, by any reason, if any DB2 stored proc or WLM or IMS or transaction got disconnected, as of now, whenever this situation is occurring, they are, forcefully going to restart IMS or DB2 or whatever may be the things. So in the same scenario, do we have any known issue with the IMS connect as of now here? Whenever IMS or IMS connect, they are passing or doing this sync point, either in phase one or phase two, whatever we can say that. In between of them, any reason could be network or transaction or any unscheduled outage, something is happening. So how it is, tackling or, handling this kind of issues? Do we need to restart IMS connect or IMS, or automatically connection will establish? Or do you know any known issue with that?
Yes. So no, you don't. For these problems, which are basically, as I can understand, these are sync point processing problems, you don't need to recycle or restart IMS Connect for that purpose. What happens is that particular unit of work might not go through. I won't say might not go through, it won't go through, right? There are a lot of things by which IMS Connect can be optimized. For example, one common problem could be, when the IMS Connect client has to send an ACK or a NAC to OTMA, and the OTMA cannot indefinitely wait for that ACK or NAC to be received, right? The IMS Connect client might go down in the meantime. So there is a timeout feature available in OTMA, which you can obviously optimize according to the volume of transactions that happens at your shop, or for that matter at any particular point in time of the day. There are some points of time in the day where the transaction volume could really go high, and things like that. So that is one optimization that usually should be done on the OTMA level. And apart from that, if there is a subsystem failure, so for example, if there is some failure talking between the IMS subsystem and the other subsystem, I think then that is an RRS. Then that is a separate problem altogether. I mean, you know, the unit of work will definitely go down, but then as you can understand, it might not have to do with IMS Connect at all. It might be a problem entirely in the other subsystem. So again, I know it's a very if I can say I try to answer it, but I know it's a sort of a vague answer. But the scenarios are so many that, you know, we have to take it on a case by case basis, right?
Okay. And do we have auto connect yes or no kind of parameter or feature here?
I won't say a yes or a no over here, because I have to confirm that before I can provide a reply.
No, got it.
Yeah.
Okay, sure. Thanks, Subhashish. Thanks once again.
Yep. Thanks a lot.
Yeah. Bye. Thank you.
Yeah,
Hey, Norm, thank you. Thanks for time.
Yeah, and just
Thank you.
Just to reiterate, everybody, thanks for the session. We've got the feedback here. We've just run over probably by 1 minute. So thanks, good questions there. And some of those questions, by the way, about the timeout parameter, we did mention that early on in the session, I think. And I think AJ didn't join at that point. So that's fair enough. But thanks for your feedback, guys. That is the link there to the feedback, and look forward to the next session. So Subhadash is going to be doing another session on Thursday, so that probably to complete the 3. So that one is going to be understanding how the CM0 CL1 input message sent to IMS Connect works, and that's at 9 o'clock on UK time on 9th of February. But there are some other sessions coming up today. So there's one other session today, which is coming up, which is at 12 noon, which is IMS native ZOS DDL utility for IMS DDL. So we look forward to seeing any or all of you on that. So have a great break, and look forward to seeing you on the next session of the IMS stream. And thank you very much, Subhadash, for that session there, and for everybody who attended. Thank you. Bye.
Thank you. Bye-bye.